everyone. I am a student of Jajban College. My major is computer programming analyst. Professor Reza is our teaching instructor of applied machine learning. This is applied machine learning assignment 3. The idea of the current assignment is to identify what we have learned about convolutional neural networks, chapter 5 of deep learning with Python book. There are some new concepts and challenges that we will face in the current assignment, and we need to resolve each issue and move to the next step. Now I am going to explain my assignment. In part A, image convolution, import the image. Then first let's see the image. This is the part of convolution with 2D kernels. This is a standard convolution. Define a function to squash out the values between 0 to 255 range. This function will be called in the following function since the resulting array values can be negative or greater than 255. Define a function to apply a conv 2D kernel to an image. This is line detection. Here are 4 conventional to detect horizontal, vertical, and lines at 45 degrees. Now I am going to explain the question 1 and 2. I have created a kernel named kernel of 45 to detect the 45 degree. And using the kernel to image, I have shown the output images using matplotlib. In question number B, I have created a kernel named kernel underscore of underscore 135 to detect the 135 degree. And using that kernel to image, I have shown the output image using matplotlib. Question number 2a, I have applied the given kernel to image and get output array using conv underscore 2d underscore kernel built function and for the output using matplotlib. In question number 2b, I have applied the given kernel to image and get output array using conv underscore 2d underscore kernel built function and for the output using matplotlib. In question number 2c, I have applied the given kernel to image and get output array using conv underscore 2d underscore kernel and built function and for the output using matplotlib. 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 10 are explained in the notebook. Now I am going to explain part B, importing libraries, preparing the data set, load the data set, building the neural network model, custom callback class of logging. Create a custom callback class to be called during the training. Instantiate the custom callback. Training the network. Train the network with train underscore image and train underscore levels. Plotting the results. Define a function to plot the results. Call the results plotting the function. And now I am going to give the answer of questions 0, 3 to 10. The question number 3, did the network presented signs of overfitting? If so, in which phase? Yes, there is overfitting. The overfitting starts after the 10th epochs. Here is the question number 3 answer. And question number 4, write down how many layers this model has and identify their types. There are totally 5 layers. The layers types are convolution layers, max polling layers, flattened layers, dense layers. In question number 5, briefing explain what is the purpose of each of these layers. Convolutional layer is used to blur and sharpen images. Max polling is a polling operation that selects the maximum element of the region of the future map covered by the flatter. Flattening is converting the data into a one-dimensional array for inputting it to the next layer. Dense layer is used to classify images which came out from the convolutional layers. In question number 6, add one more convolutional layers to our model and run it again. I run the cell below containing the functions model.compile and model.fit. Now the training is complete. It is running the following cell containing the result underscore 14 function. In question number 7, compare the results and describe what are the difference between them. When increases the convolution layers, the accuracy increases for test dataset and validation dataset, but the overfitting is reduces slightly when increases the convolution layers. In question number 8, comparison when we use the dropout layers, the overfitting happens, but the dropout layers reduces overfitting considerable amount compared with the above two occasions, with one convolution layers and two convolution layers. Here is the explanation I already write down. In question number 9, the purpose of dropout layers is to prevent the overfitting in the running model. How dropout layers work? Dropout layers prevent overfitting due to a layer's over-reliance on a few of its inputs. For example, in my code, I have used dropout 0.2. It means it drop out the 20% of neuron in the dense layer. In question number 10, when increases the number of filters from 32 and 128 and increases the number of neuron 128 to 256 in the dense layer and change the max polling kernel size 2,2 3,3. The validation data accuracy increases from 0.64 to 0.69 and test data accuracy increases to 0.88 to 0.99. Thank you for listening me. I hope you really enjoy it.